Hello and welcome. Today we'll be looking at the factorization of algebraic expressions that are often described as difference of squares. Let's begin. So, what do we mean by difference of squares? Well, it just means difference of two squares. So, for example, 4 squared, uh, 4 squared minus 2 squared is an example of difference of squares. So it just means you're subtracting one square from the second square. Okay? And likewise, instead of these being numbers, they can be letters which actually represent numbers. So we can have p squared minus q squared. So this is still difference of two squares. So what do we mean when we write it like this? Well, an actual expanded form, which we're going to talk about in the expansion section, p squared minus q squared actually means p plus q into p minus q. Okay, we're going to prove this to you when we talk about expansion, but for now let's just take it as p plus q into p minus q. So when you have difference of two squares, the sign, for example, 4 squared minus 2 squared can also be written as 4 minus 2 into bracket 4 plus 2. Okay, you want to try that to see whether that's really true. Yes. What is 4 squared? 4 squared is 16. What is 2 squared? 2 squared is 4. So 16 minus 4, that will give us 12. So let's see whether this rule is really true. So 4 minus 2, that's 4 minus 2 gives us what? 2. And then 4 plus 2 gives us 6. So 6 times 2 gives us 12. So we see that 4 squared minus 2 squared is equal to 4 minus 2 into 4 plus 2. So therefore, anytime you have a difference of two squares, what you actually write out from there is that the first term and the last term, the sign between them, you're going to write them twice, and then the sign between them is going to be opposite. So for the first one, it's going to be a positive sign. For the second one, it's going to be a negative sign. So if you have difference of two squares, let's say r squared minus s squared, how do you write them out in full? So it's going to be what? One is going to be r minus s, and then the other is going to be r plus s. So the signs of one will be opposite the signs of the other. When we talk about expansion and we expand it out, you see the reason why eventually it results back to this when we remove the brackets. So, but for now, let's concentrate on the fact that when you have the difference of squares, it actually refers to two factors. One has a positive sign, the other has a negative sign. So let's look at a few examples. So x squared minus 16 is an example of difference of squares. So if you want to write this, we're going to write this as what? X, remember 16 is 4 squared, so x minus 4 into what? X plus 4. Okay, what about x squared minus 25? What would that be? We know 25 is actually 5 squared, so we can write that as what? X minus 5 into x plus 5. So the difference there is that the two of them have different signs. Now let's look at an example. So factorize x squared minus 36. So well, the first thing here is that let's rewrite this. This is going to be x squared minus 6 squared. Okay, now both of them are squares. So this is a difference of what? Two squares. So how do we write this in a bigger form? So this is going to be what? X minus 6 into x plus 6. Okay, so x minus 6 into x plus 6. So that's how we factorize it. And based on our previous discussion, when you have difference of two squares, we used the numbers 4 and 2 to explain. We can use practically any number. Let's say 9 9 squared minus 3 squared will be same as equal to what? 9 plus 3 into 9 minus 3. Okay, so what is 9 plus 3? That is 12, multiplied by what is 9 minus 3? That is 6. So the total of that is 72. Okay, so what is 9 squared? That is 81. What is 3 squared? That is 9. So when you subtract 9 from 81, 11 minus 9, it leaves you with 2. So the value is 72. So we see that 72 is equal to 72. So this is called the difference of squares. So when you have two squares and you're subtracting from each other, you're going to write them, write the first term, subtract the second term from the first term as one of the factors, and then add the second term to the first term as the second factor. What do I mean? So x squared minus a squared. So the first term here is x, right? So we're going to subtract the second term, which is a, from x. So x minus a. So that's going to be our first factor. So what's going to be the second factor? The second factor, we're going to add the second term to the first term. So that's going to be x plus a. So anytime you have difference of squares, this is how you factorize it. Sometimes they hide the squares so that you don't know that it's actually difference of squares. So how do you go about that? Well, the first thing is that you're going to have to factorize twice. So the first step is you first do a first factorization, which will expose the difference of two squares, and then you factorize the two squares. Okay, so here we first do a first factorization. So we divide through by 2. Okay, so that's going to be 2 into what? X squared. 98 divided by 2, that's 49. Now we can see the perfect square here. So we can write this as 2 into what? X squared minus 7 squared. Okay, so how can we factorize x squared minus 7 squared? Recall from our previous discussion, this is going to be 2 into what? X minus 7. So you subtract the second term from the first term, and then for the second factor you add the second term to the first term, x plus 7. So we have successfully factorized 2x squared minus 98 into 2 into x minus 7 and into x plus 7. So in this example, we do not see an obvious difference of squares. So, well, most times they want to hide the difference of squares as much as possible so that you don't know that it's difference of squares. But we look very closely, there's something we can do to expose the difference of squares here. So first, what is common to both sides? So 3 is common to both sides, yes. What else? So we can factorize negative 3 out and see whether we can change this into difference of squares. So what do? So we take out negative 3. So negative 3 into, so if you divide negative 3x by negative 3, what you have is positive x squared. Then plus 108 divided by negative 3 will give us negative 36. Oh, now you see the square. Yes. So next we write negative 3 into x squared minus 6 squared. So how do we factor difference of squares? So negative 3 into x minus 6 into x plus 6. Factorize 16x squared minus 100. Okay, so here we do see that 100 is what can be expressed as a perfect square. 16x squared can also be expressed as a perfect square. So we don't need to divide through. So we just write this as 4x squared minus 10 squared. Now it's a difference of two squares. So how do we factorize? So we go ahead, it's going to be 4x minus 10 into 4x plus 10. Is it possible to factorize numbers that are not squares? Yes, it's possible. How is that possible? Well, you'll recall that we can make this number a square in a way. So how do we do this? So we can rewrite this as what? X squared minus root 5 squared. What is root 5 squared? Well, if you can refer to the source section, root 5 multiplied by root 5 is equal to what? 5. So root 5 multiplied by root 5 is the same as root 5 what? Squared. Okay? Root 5, another way to write root 5 is 5 raised to power half. Okay? So if you square 5 raised to power half, what do? You multiply the powers. 2 goes in 2, so what you have is 5. So we can write it this way. So x squared minus root 5 squared. Okay? So now that is in as a difference of two squares, what do we do next? So we can write this as x minus root 5, okay, into x plus root 5. Sometimes we can, instead of having just a single variable term like x or y or z, sometimes it could be a composite algebraic term like 2x minus 3, x minus 5, or x plus 5, which is expressed as a square. So the same rule still applies. So therefore here we can write 2x squared through 2x minus 3 as 2x minus 3 squared minus root 12 squared. Okay, so and then we can express this as 2x minus 3, because it's a unit, you write it as a unit, minus root 12 into 2x minus 3 plus root 12. Well, root 12 is can be broken down, so we can write it as 2x minus 3 minus root 12 is actually root 4 times 3, so that is 2 root 3. Okay, and 2x minus 3 plus 2 root 3. Well, if you don't know how I arrived at 2 root 3, I will advise you to take time to watch the videos on surds section, or which some people call radicals. We tried to explain how to simplify surds and break it down from bigger number to much more manageable numbers. About 2x plus 5 squared minus 16. Yes, we can write this as 2x plus 5. Sorry, I said 2x minus 5. It's 2x plus 5 squared minus 4 squared. So we can write this as what? 2x plus 5 minus 4 into 2x plus 5 plus 4. Okay, now if you simplify, this is going to be what? 2x plus 1 into 2x plus 9. And lastly, you can have two composite terms, algebraic terms, being squared, and it's still difference of two squares. So 3p plus 2 squared minus p plus 1 squared. So how do we factorize this? Well, the same way we have worked so far. So it's going to be what? 3p plus 2 minus p plus 1 into 3p plus 2 plus p plus 1. Okay, so now we can simplify this. So this is going to be 3p plus 2 minus p minus 1, okay, into 3p plus 2 plus p plus 1. Okay, 3p minus p, that leaves us with 2p, plus 2 minus 1 leaves us with plus 1, into 3p plus p gives us 4p, and 2 plus 1 gives us what? 3. So when you factorize 3p plus 2 squared minus p plus 1 squared, what you have is 2p plus 1 into 4p plus 3. So you want to remember, when you are working with difference of two squares, that when you have two squares, let's say a squared minus b squared, to factor it, all you need to do is what? One of the factors, you're going to remember this is the first term and this is the second term. So you're going to add the first term to the second term in one of the factors, and you're going to subtract the second term from the first term in one of the factors. So it has two factors because it's a square, it's got two factors. So the first factor is the first factor minus the second factor. In this case is a minus b, and then the second factor is going to be the first factor plus the second factor. In this case it's going to be a plus b. That's it on factorization of algebraic expression relating to difference of two squares. Thank you for watching.